All right. Hey, everyone. Can you guys hear me? Awesome. Yeah, so today I'm going to be talking about data labeling and fintech. I know it's after lunch, so I'll try not to put you guys to sleep. But yeah, we're going to be talking about some advanced techniques and how you can leverage programmatic labeling and ideally LLMs to advance your modeling efforts. So my name is Sailesh Patnala. I go by Sai. I'm a founding engineer at Pave.dev. We focus on building AI and ML solutions to power cash flow underwriting. Previously, I worked at BlackRock doing data engineering for fixed income research, where we were analyzing SEC 8K and 10K filings. And a big soccer fan, grew up in the UK, so if anyone's into that, we can chat later. Woo! So a little bit about what we do at Pave and why this problem actually we care about a lot. So we're delivering AI-powered analytics and scores on consumers' cash flow. And we do this by ingesting transactions, balances, liabilities, and credit reports from various different sources and different formats, and unifying that in order to be able to understand a consumer's cash flow. So we provide analytics and scores to help underserved borrowers. We also help adjust credit limits based on their affordability. And using all of that, we're also able to forecast delinquencies. So kind of jumping right in, let's start with the definition of data labeling. So it's the process of preparing data sets for algorithms to learn patterns. So this doesn't necessarily have to be machine learning algorithms. It can be some kind of statistical model or anything else. And when you look at data, there could be multiple patterns that you want to extract from it, which is not surprising. But each of those different patterns will likely need different labels, and each type of label will come with its own set of challenges. It's also referred to as data tagging or annotation. So why is this important? Obviously, better labeled data can help with improved model performance. We have the saying in machine learning, which is garbage in is garbage out. So what that essentially means is if you try to train a model on incorrectly or badly labeled data, your model is likely not going to produce anything useful or predict anything at all in some scenarios. The second point here around interpretability and fairness is what I find really interesting. By focusing on data labeling and data quality overall, you can start picking up on trends within your data and really understand your data well. So you can identify biases that might occur, and in the case of use cases like credit risk or decisioning and underwriting, you can make sure that your data set is set up correctly to ensure fair decisions for your customers. So the agenda for today, we're going to start talking a little bit about machine learning and consumer finance and contrast that with other tasks and other domains and why it's challenging to do so in consumer finance. And then we're going to talk about how we've done data labeling with human labelers and how we're starting to move on to more advanced techniques like programmatic labeling and also leveraging LLMs. So comparing and contrasting traditional NLP tasks like entity recognition and sentiment analysis, a large part of the success with these tasks is around the abundance of labeled data sets. So for NLP, pretty much any written text or anything on the internet can be labeled very easily, and there's good labeling tools out there to do this. And kind of unstructured data in general can be consolidated, and there's standard metrics from research around how to evaluate them and how to maintain the models in production. When you look at something like credit risk or spend recommendation, there's a lack of labeled data and also good labeling tools. And the data is often fragmented in different formats and different systems, and there's huge amounts of data engineering work just to even get a data set that you can work with. And once you're at that point, there's non-standard metrics on tasks and metrics based on the product that you're building. You have to evaluate your model differently and what impacts it has and how do you evaluate it over time and keep it up to date. However, I think we're at an inflection point in fintech. There's massive data liquidity in the ecosystem. So we have companies like Plaid, MX, Finicity that are providing bank transactions and balances data via APIs. You have Marqeta and Unit that are banking as a service providers providing other bank-related information, core banking services like Fiserv and FIS, and also for income and payroll-related, you have Argyle and Pinwheel. So there's a lot more out there that obviously I haven't put on this slide, but the point is that we have a rich ecosystem of APIs to be able to collect large amounts of consumer financial data. So a large part of our focus at Pave is on transaction data, and what we learned very early on is that inaccurate transaction data can lead to poor experiences. So what do I mean by this? And let's take a look at some cash advance transactions here. So you can see these are different cash advance transactions in a user's bank account, and the aggregator has miscategorized this as payroll. So if you rely on these categories to make lending decisions, that can result in inaccurate risk assessments. So there's two potential scenarios that could happen here. By taking these bank transactions as income, maybe you give out a loan or a cash advance to someone who might not actually have income, and that results in default. Or you don't give them enough, and that results in churn from your problem if you're not able to actually capture the payroll that's in their bank transaction data. So what we try to do, and what we've been able to do with data labeling, is actually correctly identify these kinds of transactions and other scenarios as well by correctly tagging them. So you can see you're identifying the different $30, $50 amounts as cash advance, and also the like $9.99, which is basically a subscription. So we've been able to do this with data labeling, and we're going to look at basically compare three different types here of three different approaches to data labeling. So starting with human labelers and kind of manually labeling that, we're going to look at programmatic labeling, and we're going to talk about LLMs and how they can help here. So when you get started with human labeling, there's kind of two main things you want to think about. Like, how do we frame this labeling problem, and how do we set up the right labeling workflow to enable our human labelers to efficiently label data? So the first thing you need to answer is, what exactly are you labeling, right? Is it going to be a simple true-false Boolean kind of label? Is it going to be a categorical? If so, then how many categories? And we found it really important that all stakeholders should be aligned on this. So the labelers that are going to be doing the labeling, the ML and data scientists that are building the model, and as well as the product teams that are taking advantage of the output of this model into your product. And you also need to look forward a little bit and think about the metrics of evaluation. So how are you going to evaluate this model that you're building with this? And make sure you're labeling the ground truth. So if you're labeling things in your data that are not going to be used to evaluate the model against, then you're not labeling the ground truth. The last piece here, I think, and is something that can be easily forgotten, is dealing with ambiguity. So there could be scenarios where you don't have enough information or you cannot confidently assign a label in particular cases. So what do? If you think about like a Boolean categorization problem, you have yes, no, maybe you introduce a third category called I don't know. But what does that mean for your product? Or maybe you just skip it and don't label it. So there's some decisions that you need to make with your product team and with the data scientists on how you want to deal with that, what are the trade-offs, and how does that impact your modeling efforts. So once you've made maybe not so straightforward decisions and you've traded off certain things, you want to think about how do we make this process as simple as possible and enable your labelers to label as much data as you can as quickly as possible without sacrificing quality. Right? So part of that equation is, what is the view of the data that the labelers are going to look at? You don't want the labeling process to lead to fatigue and thus reduction in quality of your labels. So you want to make sure there's enough information for them to confidently make a labeling decision, but also not too much information where they're kind of bogged down and it slows them down. And the last piece is, how do you input this data? And this kind of transitions into tooling, which is kind of what we're going to get to next. So you guys are probably wondering, are there any tools out there that can make this easier and set up these labeling workflows? Short answer is yes. We've actually tried out Label Studio. It's open source, pretty easy to pretty easy to self-host, and they have an available SDK to help you move data out of your data warehouse into the labeling tool, and once you've done your labeling, back into your data warehouse to do analysis and actually build your model. But what we learned is actually it doesn't fit the use case for us very well of tabular data. So when we're looking at transactions, we often need to look at a series of transactions and the entire user history to be able to make a decision on labeling a particular data point. So there's actually no magic sauce. We've been pretty successful using just Google Sheets. The UI is customizable and flexible for our use case of tabular data. And we found it to be relatively scalable with like a 5 million cell limit. So you can have a few 100,000 rows in one Google Sheet. You can have multiple Google Sheets. And there's a good variety of libraries out there for you to kind of bring all that back in to your data warehouse and kind of analyze and use that towards your model. So before we dive into kind of human labeling, how we've done that, I want to introduce the problem that we're going to work with throughout this talk. It's a pretty simple problem. We want to identify rent transactions among a user's bank transactions. The reason this can be complicated is rent is not always paid to the property manager or a leasing company. It can be paid by checks and Venmo. Maybe you're paying your roommate, so that will show up as Venmo or Zelle. And this is important to us and our customers for the following cases. So KYC, identity verification. For underwriting, it's a big part of understanding a user's cash flow, like how does their rent impact their ability to pay off other debts and liabilities. And for personal finance management tools, it's just educating the user of their rent and kind of what their cash flow looks like. So going into how we've done the labeling for this particular problem, this is the labeling view that we've kind of used and our labelers have used. So we have the description, the amounts, the date, and we've also leveraged some of the cleaning and tagging that we're doing in-house. So that's what's helpful here to distinguish a lot of the transactions that aren't rent. So if you look at the first example, like a Sprint transaction, it's a payment to like your phone bill. That's very clearly not going to be rent. And then PNC banks. Zelle is maybe a little bit more complicated. You need to actually look at the description, and that's why we have that field there as well. And these are examples that are rent, and the amount and the date play a big role in the decision making here. So you'll see that the amounts are either the same or similar, and the payments occur during the first few days of the month. So the first 3 examples are basically check payments to a property management company. The next 3 or 4 are kind of, just by looking at them, you don't know what they are. But given the amount is consistent and the transactions always occur on the 4th of the month, it's kind of evident that it's rent. The next 2 are examples of Zelle payments, and the last 2 actually have the keyword rent in them, which is also, there's a lot of transactions like that. So human labeling and manually doing that labeling is high quality. So you have your labeler spending a lot of time looking at this data, but it's expensive. So we recently started tracking a lot of our labeling efforts, and we found it to be very time consuming. So 20,000 transactions took our labelers about 24 hours to get confident examples. The second point is hiring these labelers is also expensive. They need deep domain knowledge of the problem, really need to understand that problem space, and really understand the data. So our labelers have looked at hundreds of thousands of transactions, and they kind of live and breathe that transaction data, and that's what allows them to label the data at a high quality. So where do we go from here? Like obviously it's gonna take forever for us to get a large enough data set to build any kind of ML models or advanced machine learning algorithms. One solution here is programmatic labeling. So, and a big player in this space is Snorkel, which we've been exploring. Snorkel basically has a data-centric view of ML. And what do we mean by that? So by keeping your machine learning model constant, you can improve the model's performance by improving the quality of your data set. And improving the quality of your data set can come from many different things. That could be just more examples. It could be more features and high quality features. or it could be just improving the quality of the labels on your existing data set. And Snorkel has two main concepts of labeling functions and label models that we're going to talk about today. So this is a high-level overview of how you would generate a label training data set using Snorkel. So you and your team will kind of write these labeling functions, and labeling functions are essentially any kind of signal that you can extract from your data. So you've done some data analysis, you have some heuristics, you've looked at some data points, and you know that, okay, this particular rule or something can give me a signal on whether this data point, going back to our problem of rent, maybe you're looking at whether you like a write a regex or something that can classify this as rent. The reason these are interesting is because your labeling functions don't need to provide all the signal that they need. And that's because your label model will use weak supervision to kind of aggregate those different labels. So if you have, let's say, 10 labeling functions, your label function applier will generate 10 different labels for each data point, and do that for all your data points. And then your label model will aggregate and figure out, okay, based on the signals that I'm seeing here, weight each signal differently and generate one data label per data point. So here's an example of what I mean by a labeling function. So going back to our rent problem, this is a simple regex that kind of looks at the transaction description and is picking up things like apartment and property and realty and housing and labeling them as rent. I want to highlight the label abstain here. And this is kind of in the context of Snorkel, and it's essentially telling the label model, which is doing the aggregation, that this particular labeling function is not able to provide any signal. And the label model can use that to say, okay, this particular labeling function doesn't give me any signal, I'm just going to maybe overweight something else. So lastly, the label model. So like I said, it helps with aggregating labels from all these different labeling functions to produce one label data point. Naively, this could just be a majority vote. So if you have 10 labeling functions and 7 of them are saying that this particular data point is class A, then we just go with class A. But Snorkel uses weak supervision and provides you optimized models to kind of leverage this and generate large labeled data sets. So we ran this against our basically human labels, and these are kind of the results that we've gotten. We've assumed 99% for our human labelers, given their high quality, and they spent a lot of time on them. Like I said, 20,000 transactions took us 24 hours. With programmatic labeling, we were able to achieve a precision of 94%. And the actual runtime to generate the labels doesn't take that long, but I've written kind of 2 to 3 hours, given the analysis that you need to write your labeling functions and all that stuff, and iterate on them a little bit. So that's good. We've kind of cut it down from maybe a few, day or a few days to maybe a few hours. But where do we go from here? Like, can we make this even faster? Can we cut out that time of doing that data analysis? And that's where we thought LLMs could come in. When ChatGPT and OpenAI came out, we were really excited to see if we could cut this down even more and help us generate large labeled data sets for the models that we're building. So kind of diving into how that would work, I'm sure a lot of you guys already know about prompt engineering. So kind of setting that persona and establishing the objective. What is the task? So we kind of leaned on what we had done in the past with human labeling, the learnings that we've gotten on how to set up those labeling guidelines that I talked about, and kind of applied them here as well. And then you provide labeled examples. So we're kind of leveraging the few-shot learning technique in machine learning, so giving it some examples and telling it these are the answers for these examples, and kind of iterating on that. So that will generate some labels. You kind of do your error analysis, see what it's getting wrong, and then adding some tips into the prompt to help it get better. So let's run through that exercise for a bit. So this was like a V1 of a prompt that we did for bank transactions. So establishing that persona, you're a business analyst expert in consumer finance. You're looking at bank transactions. Your task is to label yes, no, or I don't know for these rent transactions, and you're putting in a couple of examples and what the response for that should be, and then you pass in the actual transactions that you want to label. So that was good. I mean, it kind of worked, but not well, and we saw some of the issues that were coming up. So it was mistaking mortgage payments for rent, so we kind of put that in as a tip, saying mortgage payments are not considered rent. Airbnb payments are also not rent, giving it hints that rent payments usually occur either at the beginning or at the end of the month. And we changed this a little bit now to introduce this concept of a confidence score. And this was kind of to start to understand why is the model predicting certain transactions as rent or not rent, and kind of get into how it's thinking. We took this even further, actually, and this is kind of a screenshot of what we put into the UI here. So you'll see we've extended that concept of confidence score and really asked it to explain yourself, like explain your thought process behind producing this label. And this is just, we've actually noticed that it performed better by doing this just by the nature of how LLMs produce their predictions. So we're asking it, like, identify the counterparty in this transaction. What is the transaction's purpose? What are the dates, the amounts, and how does it compare with the user's transaction history? And we've passed in 10 transactions here. The first 5 being payments to a duly property, which are actually rent payments. And the last 5 here are payments to a credit union, so some kind of bank loan payment of sorts. And this is what it returned. Obviously, when you use the API, you can kind of parse this into a CSV and do that programmatically. So I just put it into a table for us to look at better. So if you look at the thought for the very first transaction, it's able to identify trends around, okay, the amount is staying consistent over a few transactions. The date being at the beginning of the month kind of also suggests that it could be rent, and then it's also identifying the counterparty that is duly property. And the first 5 transactions here are actually labeled correctly. It has a high confidence score, and they really are rent. But what is interesting in this example is it also kind of thinks the next 5 transactions are rent, even though they're not. So one takeaway from this is, even though it is able to identify the counterparty as San Antonio Credit Union, it doesn't know that it's a credit union. It's not able to understand that that's not a property management company. So we ran this against our human labels, and as you can see here from the metrics, it's not great. We had to shorten the dataset size that we use given the token limits and API constraints from GPT-4. We did run it on GPT 3.5 as well, and we were able to get a lot more examples done in a matter of a few minutes. But the accuracy was even worse. The precision was even worse. So yeah, stacking all those together, this is what that looks like. And you're probably wondering, like, okay, LLM is maybe not that great for this particular task, and that's kind of what we had learned as well. So our learnings here is GPT is good at some things. So it's able to identify merchants, but it's not able to understand the type of the merchant. So it's able to identify, like, duly property is the merchant in this transaction, but it doesn't know that, and it's also able to identify that San Antonio FCU is the merchant in this transaction, but it doesn't know that duly property is a rent company or a property management company, and San Antonio is a credit union. It's also able to identify recurring transactions based on the date and the amount that we're providing, but it's not able to distinguish rent from other kinds of payments. And it's also able to identify duplicate transactions. So our journey so far hasn't been very promising, but we're still bullish on LLMs for data labeling. So this is kind of the expectation versus time graph I'm sure you guys have seen for hype cycles. So when we started out, we were at, like, okay, human labeling is our only option to get high quality labels, but it's expensive. And when ChatGPT came out, we were like, oh great, LLMs are gonna solve all our problems, we don't need to do any data analysis. And after trying it, I think what we learned that they are powerful, they are able to understand transaction data to a certain level, but it's not a silver bullet. And I think where we go here from today is really trying to understand how to properly leverage LLMs to accelerate data labeling and modeling efforts. So our next steps here are to try and provide more information about these transactions. So we kind of went in very naively saying, we think that LLMs will be able to identify and extract information from this data, but what we learned is it's not. So by providing things like clean merchant names, which we've already kind of done in-house, we think that will help it differentiate different types of merchants. Providing the tags as well that we're already building. We also want to try to provide more labeled examples in the prompts. Obviously, this comes with some constraints around the token limits we have with GPT-4. Another interesting next step here we're thinking about is to maybe use LLMs as a week prior. So we've seen that with programmatic labeling, you can kind of write these functions that are providing weak signals about your data. And when you combine those together with programmatic labeling, you're able to get relatively good accuracy and precision on your data. So why don't we try to use LLM as a labeling function? And the fourth piece is basically, let's just train the LLM on our custom data sets in-house and kind of use that. So as we come to a close here, we've seen that LLMs are not a fit for all problems. So this problem of identifying rent transactions does require a lot of expertise. And LLMs might not have that, right? Prompt engineering, we were kind of naive about it, and we learned that it actually does take a lot of time. And you do need to do a lot of data analysis to get your prompt engineering correct. And that leads into the next point around any kind of approach you take to programmatically generate your labels, you will need ground truth labels to evaluate that. And there'll be a tolerance level for you to say maybe at 95% precision against human labels. I'm going to say if I can generate 1 million labels, then my ML model will be able to generalize, and we can tolerate that 5% lack of precision. And I think the biggest takeaway for us here is that a lot of these consumer data is hard to label for your particular problem and still require a lot of human feedback. So just to tie out what we've talked about overall, we've seen the importance of labeled data sets for model development. We've talked about that. Human labeling is really a very good first step because it forces you to understand your data really well. We've looked at how tools like Snorkel can help augment your human labeling efforts. So all the learnings that you've gotten from your human labeling efforts, all the data analysis that you've done and heuristics you've collected, you can kind of feed that into Snorkel, and they fit almost one-to-one for labeling functions, which is great. LLMs being very capable are not a silver bullet for all your problems. And kind of the goal for us here is to really start leveraging data labeling at scale. And we have an emerging opportunity here to increase access to financial services, given the data liquidity we have in our ecosystem. So that's all I have for you today. Thank you, and I'd like to thank Moov and fintech DevCon and all the sponsors for giving me this opportunity to talk here. I hope it was useful, the kind of journey that we've had with LLMs, and we're still excited. I think LLMs are gonna continue to get better, but there is an aspect of learning how to use them correctly for your problem. Yeah. Yeah, so the question is, how do you get the resources to do your human labeling, and is that right? Yeah, so I mean, for us when we started, we're a small startup, we're 15 people, and we all labeled data. When we first kind of built the product, it's like, we need to understand this data to really be able to build any analytics on top. So it started with each one of us at the company spending time looking at the data and actually labeling it ourselves. And once we kind of established like, okay, identifying a merchant is kind of the table stakes for us to do anything here. we then started formulating the task as like labeling guidelines and hired people to kind of follow those guidelines and generate labeled data sets for us. Yeah. Yeah.
Well, it's a question about the main topic, but when you're working on those prompts, how do you manage like that development flow? Because I imagine you're making changes to the prompts and evaluating them against each other. Do you have any tools there?
Yeah, so I mean, we use a tool. So the question is, when you're working on this prompt engineering and working with different prompts, how do you kind of evaluate them against each other? So we use a tool called weights and biases generally for model development, and that's kind of what we leveraged here as well. So whenever we run this, run a particular prompt against a large data set, we generate these precision metrics, and we know which prompt resulted in what precision. And we have like a table view that we can see, okay, this prompt had more false positives or more false negatives. We generate those metrics and store them in weights and biases, which allows us to compare prompts and models generally. That's how we approach model development as well. Yeah. Yeah.
When you label your data with human labelers, how did you, one of the examples you used was around revenue, and obviously you can see those 4 different transactions to be able to have that verification.
Yeah.
When you were labeling that data, how did you sort of deal with privacy and anonymization and that side of things versus like, this is an entire person's sort of set of transaction data?
Yeah, so we don't look at basically everything. So depending on the task, for rent, for example, we know they're not going to be credits, right? We know rent transaction is not going to be credit. We're doing filtering around, okay, we don't need to look at $10, $20, $30 amounts because that's not going to be rent. And we have PII controls that we do when we first ingest the data anyway. So when our labelers are looking at it, they're not seeing the PII.
Thank you very much for educating the ownership. Similar question. I noticed that there were some things like blocked out or redacted from those examples. What was that that was blocked?
That was PII basically that we've blocked out for the purposes of the slide deck, but our labelers don't see that as well.
Yeah. Okay.
Yeah.
Makes total sense.
Yeah.
Would you say you kind of are doing evergreen labeling and always going through a labeling process, or do you find it effective to like do that kind of have a true up on a regular basis?
Sorry, I didn't understand it.
Are you doing evergreen labeling? You have labelers running every single day. Do you kind of do a periodic, okay, now it's time to do a bunch of labels and catch up?
Yeah, so the question is, do we periodically label data? And yeah, we do. So we've labeled some data, we've built a model, and we're tracking the model's performance over time. And as we get more data and the nature of the problems change, we have to relabel them. So we add on. So we don't throw away those labels, we keep them, and we introduce new data that based on the data drift that we have, and we introduce those labels as well. Yeah. Yeah.
I know you mentioned that the LLMs with GPT-4, and then you said GPT-3 was much worse, or how much worse were
It was, so the question was, we used GPT-4 and we still only got 40% precision, so how much worse was GPT 3.5? It was pretty bad, it was around like 15%. But we were able to iterate with that very quickly given, there's large token limits, so we were able to label a lot more data quickly, but it's not really usable at that point. Yeah.
Do you have a theory about why the LLMs are so bad? Like, is it just so far off how they've been trained, or is it just like not enough information for a transaction?
Yeah, so part of it is what you're saying, just the transaction description is not enough. I think the other thing is it doesn't understand that basically the type of merchant, right? That's what we realized that it's not able to understand. We can tell it to pull out the merchant, but it's only pulling out from what it knows. It doesn't know what FCU stands for example. It doesn't understand that that's Federal Credit Union, which our expert labelers kind of know that, and they're able to distinguish. So that's why kind of our next steps here are to leverage the cleaning that we're doing already and passing that into GPT. Yeah. Sorry, can you repeat that? I didn't quite hear you. Oh yeah, what programming languages do you use? We're fully a Python shop, so we know weights and biases. We integrate with Python. OpenAI has a Python SDK as well, and yeah, our entire stack is built on Python.
I know you showed like the evolution of the prompt as you guys were going along. Do you remember sort of what kind of variability you were getting on like metrics through changing the prompt?
I don't remember off the top of my. I'd have to get back to you on that one. Yeah. Yeah.
Did you sort of do any experimentation with using the LLM to sort of produce a set of labels and getting a human to sort of go through that and see if that sort of changes your like rate of labeling, like human like ability for humans to accurately and efficiently like label that data?
So your question is, have we used LLMs to generate labels and then compare that with human labels, and or see if they're correct better than human labels? Yeah, no, we have done that, and it's actually pulled out a couple of mistakes that our human labelers have made. But overall, when you put it against a large data set, it wasn't as good as the human labelers. Yeah.
Yes, if you mentioned ideas for like next steps when you're building LLMs. If you had to take a guess, what do you think would be the things that would help make it actually?
Yeah, I mean, I think we've seen that the weak supervision and programmatic learning approach has been pretty successful. So I think leveraging LLMs as a weak prior is a good promising step. And we're also looking at potentially training LLMs on our custom data, because obviously these things are trained on open data out in the internet, and they don't understand the context of transactions very well. So that's another avenue that we're looking at. And I think there's actually a talk right after this about in-house LLMs, so I'm looking forward to that. Yeah.
So you started off talking, and I've been maybe a little bit different direction from the data labeling, but you started off, you're just introducing Pave that kind of focus on credit and lending. So I'm curious, are you thinking at all, and how are you thinking about applying machine learning and AI more broadly to credit analysis, underwriting, scorecarding, that whole space? I know you're talking about the labeling today. I'm just wondering, a little bit bigger picture.
Yeah, so we are training machine learning models for and building scores like you're saying. So if you're using cash flow as an input to your, obviously that score is going to be a part of a larger model for a company. So if you think about cash advance, they're looking at transactions. That's kind of one data source they have in addition to your credit score that's coming from your credit report. So yeah, we are leveraging that. We are building these models based on transactions, how they've paid off previous loans that we can see over 2 years of bank transaction history. We're labeling that data to predict whether they would be able to pay off your particular cash advance or not in the future. So we're developing those scores already.
Yeah, thank you.
Yeah. Yeah.
One more question. I remember you guys had the models output scores. Did you see any correlation between like the score output and like the actual accuracy, or was it just by outputting the score, the model overall is better?
I didn't quite understand your question.
Like, would you notice that, like, if the model gave like a 9 out of 10 confidence, it was actually more confident, or just by virtue of having it output a score, the overall accuracy just increased on its own, not necessarily tied to what the output was?
No, I think that's where the thought came in. So the question is when GPT outputs a confidence score of 9, does that actually mean it's confident, or is that just kind of what's coming out? And we thought that as well initially, and that's why we asked it to explain itself. And in the scenarios where it was producing a high score, it was looking at the rent, at the amount and the dates that they were occurring and things like that. Yeah.
Yeah, I was asking because you said like there was like a high recall and low precision, so like I was wondering if the score would go away for you doing recall and precision or not.
Mm. All right. Well, thank you guys, and I'll be around, so if you have any other questions later on, feel free to come by.